I've got something super exciting here today. This is a Sony Betamax machine, in fact the first one I've worked on. It's a Sony SL-HF950, and somebody approached me to service this for him, and I explicitly told him that I have no experience with Betamax, and he said, "No, that's fine, I trust." And well, I appreciate the trust, and we'll see what we can do with it. Before I turn this on, I know that this is a funky little draw mechanism that comes out of here. I will check if this is all good, if there's no cracked gears or lubricant that has hardened, and I'm gonna check the power supply before I turn it on, and we'll see what this does. There's a lot of dust inside this, and most importantly there's a tape loaded here, which makes things a little bit complicated. I might have to turn this on after all and just hope that the eject mechanism works, because yeah, not cool. I really quite like the design of this primary side of the power supply. Sort of like an all metal enclosure, and then the power and then the board itself just slides out like this, and now you have total access for servicing. Doesn't look too shabby actually. I'm gonna check the caps, and it might be underway soon. Fuse is okay, which is a good sign. So a couple of things. This big 2200 microfarad cap has significantly lost value, had an increased DSR, I replaced it. DSR was also increased for this 22 microfarad capacitor. It was rated at 100 volts, I replaced it with a 50 volt capacitor because it's sitting on the same 12 volt rail as this 2200 microfarad cap, so shouldn't be a problem. I'll replace one cap here. Power supply is plugged, no smoke. It's getting warm normally. It's got 12 volts, just like it's supposed to. This, I suppose, produces a variety of other voltages. We shall see. Just for good measure, I'm just gonna replace all of these caps, because it makes no sense to keep caps that have the potential to fail in the near future, even if they're good. So, be right back. We've got a clock. Turns on. Program 9, okay. That works. Let's see if the drawer works. It unloads the tape. Wow! This is probably one of the best things I've seen ever. One of the best mechanical things I've seen. Now there's a bit of dirt here I want to get rid of. Jesus Christ, man, this is this is just, I could do this all day. This is just so cool. Well, mechanically the unit seems to work. I mean, it loads and unloads, the drawer opens and closes flawlessly, the lube is intact and everything. There's just a little problem. It doesn't play very well, or at all. Like, it doesn't play, it plays to a level where my TV just blanks the signal. You can see something of it because it generates artificial sync on picture search. So you can see that it is working, but the noise band on the bottom tells me that perhaps there's an issue with the tape alignment, with the tape path alignment. Still mode with its artificial sync is also, you know, not really very well. I think tracking might be completely off because it doesn't actually it doesn't count. So maybe there's a problem with the control pulses. Need to read up more about how that works on a beta machine. But if it doesn't count, that usually means it can't detect the sync pulses. Making some progress here. I have linear audio now.
So I have control pulses since the counter is running. And I have a picture. It's not a very good picture. In fact, it's much worse on SCART than it is on the normal composite video output. But tape path seems to be mangled quite severely. It turned out the problem was that there's a little guide in the middle of the tape that the tape is supposed to be in front of, and it was behind that thing on this tape for some reason. So I'm just spending all my time chasing smoke and mirrors, basically. Yeah, I'm fairly sure that interference is a problem with my SCART cable. Here's the video RF. It drops off here, which means I need to adjust these guides a little bit. Entry side looks okay. There's a couple guides I can adjust here and here to deal with the exit side. But yeah, looking good so far. Another quirk of the SL-HF950 is the failing LEDs for the VU meter, and this machine is no exception. You can see them in action here. The top left segment doesn't work. To get to the module, you undo the two screws on the bottom of the front plate of the loading tray. Then you undo the welding points of the VU meter cover. Then you can see the LEDs are actually bonded directly onto the copper of this circuit board. And that's incredibly unreliable, and as soon as you touch it, it's gonna fail. To repair the VU meter on this SL-HF950, I have here the VU meter circuit board. I've removed all the LEDs from the actual circuit board. Now onto these contacts I'm going to solder regular 0603 surface mount LEDs, which I have here conveniently. Next up, this machine has a little battery, a transport buffer battery, which keeps your clock and channel presets for about 30 minutes after unplugging the machine. It's a tiny little thing, 1.2 volts, 90 milliamp hour nickel cadmium cell, and of course it's completely lost its ability to keep it charged by now. You can see me unplugging the machine here and the voltage dropping to 0.4 volts immediately. And this is the replacement. It's a nickel metal hydride battery, 1.2 volts, 160 milliamp hours. I've measured the charging current that this machine applies, and it's 16 milliamps, which is right on the money for nickel metal hydride cells. So this is a perfect drop-in replacement. Alongside this machine I got a blank tape and 3 pre-recorded movies from the 80s, and I noticed when I watched the pre-recorded movies, even though the tape path was aligned, the tracking was slightly off, which means if I had the tracking control in the center position and looked really closely, I could see dropouts or noise, and contrary to what I thought, the center tracking is not adjusted with a reference tape. Instead, it's adjusted with the record control pulse as a reference for the tracking control. The service manual says that the tracking switch point should happen 7.2 milliseconds after the switch point of the record control pulse. So I set my scope to 1 millisecond per division, and it turns out that probably due to component drift, the actual switch point was at 6.6 milliseconds after the reference and not 7.2. And after the adjustment, Jailhouse Rock offered its gratitude in the form of a lack of dropouts. Beautiful to me.
Just